Good day, everyone. I'm Nizel Emelindo from BSHM 1B. Today, I'm going to report the lesson 3, the pattern of recognition as a problem-solving strategy. This topic assigned by two persons named Mustafa Naziha and Belindo Nizel, which is the one who speak this time. So, what are we waiting for? Let's go to the topic. So, what is pattern recognition? Pattern recognition is an innate congruous process of matching from the environment with information stored in the memory. So let's examine the three elements. The first element is the congruous process is innate because it is spontaneous and automatic. In other words, this is impulse to organize incoming stimuli according to the past experience is instinctive, not learned. The second element in the information in the environment has no tragic meaning, so for pattern to be recognized, there must be a match between that information and information already in the brain. The third element we can be defined pattern, a group of stimuli you can recognize as be part of the category, so everything you proceeded potentially a pattern, but some of the most obvious example are faces, words, and music. We see that pattern recognition is closely related to the top-down perception, and both case prior knowledge expectation are used to interpret sensory information. One key difference may be repetitions. Essentially pattern recognition involve detection or repeating characteristic currency or some another interviews, and this is the most basic way we make sense of the world. On a higher level, pattern recognition plays an important role, and expertise especially in the domain of games, sport. In other words, to the experts millions of patterns, example and memory and is able to recognize on the spot. Similar configuration in her environment, her pattern recognition can be compared to the intuition. To sum up, pattern recognition is a constant attempt to identify environment information that matches internal information. Let us look down pattern recognitions. Mathematics, defined as the study of patterns and relationship, the study of patterns and structures. In either case, the city Paris is the very essence of what mathematics is all about. In fact, all of the 10 strategies we are going to discuss is the pattern recognition are probably the most important strategies, and if you're only to master 2 strategies, they should be the 2 and they will take you very far. Let us look at the very simple example. All tables at a school are equilateral triangles and can sit 3 students, one of each side. If 2 tables are joined, 4 students can sit. If 3 tables are joined, then 5 students can sit, and so on. How many tables are needed to sit 50 students? This is the case when you have 3 tables and 5 students. Let us do chart number of tables, number of students. When you have 1 table, you can see 3 students. When you have 2 tables, this guy must move over here and you only have room for 1 more guy, so you have 2 tables for students. When you have 3 tables, this guy who was sitting there must move here. So again, you only have room for 1 more person, 3 tables and 5 students. When you have 4 tables, this guys move here and you guys come in and sit here. So again, only 1 new guys come in. This pattern goes on in order to sit. 50 students shown as a difference between the number of students and table is always 2, he would need 48 tables. Now in the reality, all these strategies come together when you are solving complex problems, and we will see how to solve some of those problems and how all the strategies come together in the process that called the 3-step cycle of problem solving. And that's the end of my report, to be continued by Naziha Mustafa.
In this video, we're going to discuss about problem solving with patterns. So first, let us know what is sequence. A sequence is a list of things, usually numbers, that are in order. Whereas in math, a sequence is a function whose domain is the set of positive integers. It also means an ordered list of numbers. Each number in a sequence is called a term. So 1, 7, 17, 31, 49, 71 is an example of a sequence. And we denote the term as follows. So a sub 1, that is our first term. Our second term is 7. We denote this as a sub 2. Next is 17, which is our third term. We denote this as a sub 3. And then a sub 4 is equals to 31. And our fifth term is a sub 5 is equals to 49. And last is a sub 6 is equals to 71, which is our sixth term. So we call this a sub n is the nth term of a sequence. So as you can see, we have 3 dots here. So it means that the sequence continues beyond 71.
So let's move on. What is the next term in the sequence of 1, 7, 17, 31, 49, 71? To answer these questions, we often construct a difference table. We have a different way to get the next term to the given sequence. But this time, we are going to use difference table method. So by using this sequence, we are going to get the differences wherein if the differences are already equal, we can now predict the next term. So how are we going to do that? First step is we're going to get first differences. We are going to subtract the first term from the second term. So 7 minus 1 is equals 6. 17 minus 7 is equals 10. 31 minus 17, that is 14. 49 minus 31, that is 18. And 71 minus 49, that is 22. As you can see in the first differences, they are not yet equal. So we're going to proceed to the second differences. So 10 minus 6 is equals to 4. 14 minus 10, that is 4. 18 minus 14, that is 4. And 22 minus 18, that is 4. So now our second differences are now equal. Therefore, we can now proceed to the next number in first differences. So we're just going to add the second difference to the first difference, which is 4 plus 22 is equals to 26. So we can now add upward. So 26 plus 71 is equals to 97. Therefore, the next term in the next sequence of 1, 7, 17, 31, 49, 71 is 97. So, let's proceed to the next example. So, dito naman is gumamit tayo ng third differences, as you can see, because the second differences is they are not yet equal. So, ganun lang din ang gagawin natin katulad ng ginawa natin sa isang example. In the previous example, we used difference table to predict the next term of a sequence. So, in some cases, we can use patterns to predict a formula that are called the nth term formula that generates the term of a sequence. For example, we have a sub n is equals to 3n plus 2 given this rule. So we're just going to substitute a sub 1 because we denoted this as a first term, and papalitan lang natin ng 1 ang n. That's why a sub 1 is equals to 3 times 1 plus 2. So 3 times 1 is equals to 3 plus 2 is equals to 5, and that is our first term. So next is a sub 2. So papalitan lang natin ng 2 ang n, and that's why 3 times 2 plus 2. So 3 times 2 is equals to 6 plus 2 is equals to 8, and that is our second term. Next is a sub 3, and papalitan lang natin ng 3 ang n.
So that's why a sub 3 is equals to 3 times 3 plus 2. So 3 times 4 is equals to 12 plus 2 is equals to 14. And that is the fourth term. And the last one is same procedure. A sub 5 is equals to 3 times 5 plus 2. So 3 times 5 is equals to 15 plus 2 is equals to 17. And 17 are of our last term. Therefore, the first 5 terms are 5, 8, 11, 14, and 17.